Have you ever accidentally committed a database connection string to a public GitHub repository? Or perhaps you have inherited a legacy application where production API keys are sitting in a plain text. It happens more often than we like to admit, and in today's landscape, that one mistake can compromise an entire enterprise. Today, we are diving deep into enterprise grade secret management. We are going to explore how to completely eliminate hard coded secrets in your .NET 10 applications by integrating Azure Key Vault. Let's get started. Here is our roadmap for the next 10 minutes. First, we will examine the actual security challenges of managing configurations. Then, I will introduce Azure Key Vault and how it solves these issues at scale. We will walk through provisioning the vault and the specific steps of adding secrets to it. We will look at the exact .NET 10 code required to wire this up, deploy to Azure, and finally, I will show you a live demo of it all in action. Before we jump into the code, let's make sure you have your environment ready to follow along. You will need a standard development setup, Visual Studio or your preferred IDE, the latest .NET 10 SDK installed. You will also need an Azure Active account. The free tier is perfectly fine for this tutorial. I will assume you have a functional knowledge of building ASP.NET Core web app using C Sharp, as well as basic understanding of navigating the Azure ecosystem. By the way, welcome back to .NET Mirror channel. If you are new here, please subscribe to our channel .NET Mirror. Let's start with a hard truth. Appsetting.json is a fantastic tool for application settings, but it is not a secure vault for the production secrets. Connection strings, third party API keys, and authentication tokens are high value targets for attackers. If you store these in plain text on your servers, your production environment is inherently vulnerable. Furthermore, if these files get accidentally committed to your source control, you are looking at an inevitable data breach. The real world consequences here are severe, ranging from massive financial loss to failing strict compliance audit. Modern cloud native applications absolutely require a centralized, encrypted, and heavily audited solution for secret management. This is where Azure Key Vault comes in. It is a dedicated cloud service designed specially to securely store and control access to your sensitive information. It manages three distinct types of data: secrets, like your API keys and connection strings; keys, which are cryptographic keys used for data encryption; and certificates, such as your SSL and TLS certifications. What makes this an enterprise grade solution is that it is backed by hardware security modules called HSMs, providing hardware level protection. Beyond just storage, it provides robust auditing capabilities via Azure Monitor. It also utilizes role based access control for precise permissions and includes soft delete features to protect against accidental deletions. Now, as architects and developers, we have to balance security with a frictionless development experience. We don't want to rely on a cloud service, just hit F5 and debug locally. The ASP.NET Core configuration system handles this environment transition beautifully. For local development, you should utilize appsettings.development.json or the .NET Secret Manager known as .NET User Secrets to keep developer specific credentials completely out of the project tree. When you deploy to your production environment, the application dynamically injects the secrets from Azure Key Vault at runtime. The best part, your application code doesn't change a single line between these environments. Setting up the vault is straightforward. You can use Azure CLI or simply search for Key Vault in Azure Portal. You will need to assign it to a global unique name, for example, kv-.netmirror-prod. Select your region and choose your pricing tier. The critical step during provisioning is configuring the access policies or RBAC assignments. You must ensure that your specific developer account is granted permissions to manage and read secrets so you can populate the vault initially. Once provisioned, you will navigate to the secret blade and select generate and import option. Now pay close attention here because this is where many developers get stuck. In appsetting.json, we heavily rely on columns to structure our nested configurations. However, Azure Key Vault doesn't allow columns in secret names. To map to nested JSON configurations, ASP.NET Core has a built-in convention. You replace the colon with a double dash. For example, if your code expects database settings colon connection string, you will name the secret as database settings hyphen hyphen connection string inside the keyword. The framework automatically translates this back to standard hierarchy. This brings us to the authentication. If your hardcode credentials are a client secret to access your key vault, you haven't solved the problem. You have just moved the secret to a different file. The gold standard here is using Azure Managed Identities. By assigning an Azure AD identity directly to your app service, your application can authenticate to the keyword seamlessly without any passwords. In our code, we achieve this using default Azure credential class. This brilliant utility automatically check for your local Azure CLI or Visual Studio credentials during your local debugging and seamlessly switches to the app service managed identity once it is deployed to production. To wire this all up in .NET 10, we only need two NuGet packages, Azure.identity to handle the passwordless authentication flow, and Azure extension ASP.NET Core configuration secrets to plug the vault into the .NET configuration provider. Let's look at the program.cs. It is incredibly clean. First, we read the key vault URL from your standard local configuration. We call dot add Azure Key Vault on the configuration builder. We pass in the URI and initiate our default Azure credential. That's it. In those few lines of code, Azure Key Vault secrets are now injected directly into your application configuration pipeline at startup. Now let's see how to consume those settings in our controller using dependency injection. Because we injected the key vault into standard configuration pipeline, consuming the secrets in your classes is identical to reading from local JSON file. In our API controller, we simply inject iConfiguration through the constructor. When we request configuration database settings.connection string, the framework securely pulls that value. It abstracts away whether the value come from user secrets or app settings from locally or Azure Key Vault in the production. So far, the theory is great, but let's see this is working live. I am going to switch over to Visual Studio, fire up a fresh .NET 10 web app, and show you exactly how to add the secrets to the portal, assign the managed entity, and retrieve the app settings and database connection string securely. In my previous video, I talked about how to read app settings from locally and also when you deploy to Azure App Service, how to read from Azure App Settings. I'm going to use the same code base. In the Visual Studio, I created a .NET 10 MVC app here. From my previous repo, I just copied two configurations. One is external services API base URL and the connection string. And we are trying to read these values in the index.chtml, which is our home page. And if you look at here, we are reading the iConfiguration and we are saying that retrieve the API base URL. For the connection string, we are reading it from viewbag and we are setting that value in the home controller. If you go to the home controller, we are trying to inject iConfiguration and from that we are trying to read the default connection from the app settings. Let's run the app. For the demo purpose, I'm trying to show the both the values here, but you should not do on a production application. As these values are coming from our local app setting file, now what we will do is how we can place these values in Key Vault and read from the Key Vault. Let's go to the Azure portal. Search for Key Vaults. Click on Create Vault. Let's create a new resource group. Let's put the name for Key Vault. Let's select the region. For the demo pros, I'll go with standard. And let's not change any more settings. Let's click on review and create. Click on create. Now Key Vault is created. Let's go. Now let's add a secret. As I mentioned, instead of colon, you have to give two dashes. Let's put ABI base URL. Now this time instead of local, I'll put KV during the copy. So let's do that. And let's put the secret. And remaining option, you can leave it. Now if you see here, we got an error. Basically, it's not able to create the secret. The reason is if you go to the access control, in the access control, go to role assignments. If you see here, our account has owner access, but the owner account cannot create secrets. We have to go and create explicit permissions. Let's click on add role assignment. Search for vault. And you have to give key vault secret officers. There you can go and perform any action on secrets. So let's select that. The role is selected. Let's select the user. Let's select my account. Let's click on select, review and assign. Now if you see here, our account got key vault secret officer role. Now let's go and add a secret. Now this is our key and the value. Let's go and create. Now the first setting is added. Let's add the connection string. Here also, instead of local, I'll make it as kv. Let's copy this value. Let's save this. Now our two settings got added to our key vault. Now let's go and do the code changes to read from key vault. First we need to add the packages. Let's add the first package. Now let's add the second one. Now the packages are added. Let's go to the program.cs. Let's say Azure.identity. Let's inject our key vault to the configuration pipeline. So now let's go and add this endpoint in our app settings. Here we need to put our key vault name. Let's go here. From the overview blade, just copy this URI and replace the vault URL. Yeah, now we are getting the vault name here, and if the URI is not null, we are trying to inject this key vault to our configuration. The magic here is default Azure credentials. As I already connected to my Azure account, it automatically goes and reads from key vault in the background. Now let's run the code. Now if you see here, our app is running and it is retrieving the data from key vault instead of local. Now what I will do is, let me go and make these two local only. In the app settings, I put it back to local. Now let's run the app. Now the app is up and running. If you see here, instead of reading the values from local, now it is reading from the key vault. All we did is we added two packages, injected key vault to the configuration provider. Now automatically with default Azure credentials code, it is reading from the key vault. Now what we will do is, let's go and deploy this app to Azure App Service. From the Azure portal, let's create Azure App Service. Let's select the same resource group. Let's give a name. Let's select .NET 10. Let me select the same region as Key Vault. I already have a demo plan, free tier. I'll use it. Let's click on review and create. Now our app service is created. Let's go to the resource. In order to deploy from Visual Studio via publish profile, you need to enable this checkbox. Let's select. And if you go to our resource group, our resource group has a web app and a key vault. Because I used a different app service plan that is sitting in different resource group, but ideally you should create app service plan within the same resource group. Let's go to the Visual Studio. Let's stop the app. Let's click on publish. Select Azure, Azure App Service Windows. As I connected to my Azure account, it will show all my resource groups and services. Let's select our resource group and the app and click on next. Finish. And if you see here, there are two service dependencies. As we injected Key Vault, it is showing here. And also because there is a connection string, it says SQL Server is required, but I'll ignore these things. Let's click on publish. Now the web app is deployed to Azure App Service, but we are getting an error. That is because it's not able to connect to Azure Key Vault. Let's understand this error. To understand the error details, let's add an app setting called ASP.NET Core Detailed Errors. Let's put this to true. Let's apply. Now let's refresh the app. And if you look at the error, it's not able to connect to the Key Vault. What we will do is, let's add this our Key Vault to Azure App Settings. Now we are adding our Key Vault endpoint to the Azure App Settings. Now if you observe here, we are not going to add these two settings to the Azure App Settings. Instead, we read from Key Vault. As I mentioned, in order to connect to the Key Vault, Azure App Service, we should enable Managed Identity. Let's go and enable Managed Identity on the Azure App Service. Go to the Identity, switch on Managed Identity, click on Save. Now the Managed Identity enabled on Azure App Service. Let's go to the Key Vault. In the Key Vault, go to the Access Control. During our local demo, we have added our account as Key Vault Secret Officer. In a similar way, now we need to add our Azure App Service to similar role permissions via Managed Identity. Now go and click on Role Assignment, search for Vault, select Key Vault Secret Officer. This time instead of user, go and select Managed Identity, select Members. Now select our App Service. This time let's go and select our DNMKV app demo, which is our app demo. Now we have selected our app service as Managed Identity. Let's click on Review and Assign. Now the role assignment is done. You can see our app service via Managed Identity got access to Secret Officer. Let's go and refresh our app. Now if you see here, our Azure web app is connecting to the Key Vault via Managed Identity. It is able to retrieve the values from the Key Vault. And if you look at our web app environment variables, this time we did not add those two settings, the API URL as well as connection string here, and the app is directly reading from the Key Vault. With this, we are done with the demo. Let's go back to the PPT. Before we wrap up, let's talk architectural best practices for scale. First, the principle of least privilege. When you assign the managed identity to your app, only grant Key Vault Secret Officer role. Your application only needs to read the secrets. It should never have permission to manage or delete them. Second, performance. A common concern is that reaching out to the Azure for every database call will cause latency. Don't worry, the configuration provider caches these secrets in memory upon application startup. It doesn't hit the Key Vault API on every single HTTP request. Finally, always use completely separate key vaults for your staging and production environments to ensure clean separation of concerns. To summarize our demo, it's time to stop hard coding secrets entirely, leverage .NET user secrets or app settings for local safety, and Azure Key Vault for the cloud. By utilizing .NET 10 alongside Azure Identity, passwordless authentication via managed identities has never been more effortless. With minimal code changes, you can seamlessly blend cloud-based secrets into your existing configuration pipeline while maintaining strict audit logging and environment isolation. That brings us to the end. Thank you so much for watching. If you found this helpful, please give it a thumbs up, leave a comment if you have any questions, and don't forget to share and subscribe for more videos. See you in the next video. Thanks for watching.